Okay, fine. Now, so today what we are going to see is white box testing techniques. Okay, so as we had some testing techniques for black box, we do have for white box. Okay, so we'll see today what is that and how we are going to do it. So, anyone say what is a white box testing?
We can have basic idea of the code what is going.
Yes, to test what is the code developed properly, and to check if they'll give a very basic input and check the output. Okay, so software's internal structure, code, and design will be tested here. Obviously, we will not be doing it, but it will be done by the developers. So, as we write test cases or test scripts to ensure that our testing is going on fine, the developers will also write test cases. Okay, it will not be like us, it will be a different one. Maybe I'll try to Google and show you for your understanding. See, it'll be quite different. You need not worry about it. Okay. So it'll be very different. So, what action, input, expected, and output, that much only. And they'll also be having how much coverage they are doing. Okay. So it'll be in that way. So we need not worry about our, what is a white box testing test case. But they do write test cases to check the code quality. Okay, and this is white box can also be called as glass box, open box, and clear box. Okay, the main thing is your code will be visible, the code, testing the code, okay, without bothering about the application, giving input to the code and checking if the code is giving the proper output is called as white box testing. Okay, so what will be verified in it is, as I said, we'll be doing line by line code verification. The test case, how they'll write is, they'll cover uh, line by line, this code should be in this way, so that line by line code verification. If they are having any looping conditions in there, that will also be verified. And broken parts means, see, I have a code. Okay, I have a if else statement, so I have written for if, but I have not written what an else statement should do. That is, if age is greater than 18, issue him a Aadhaar card. Okay. Else, to not issue. So this is the condition. So I have written if, but I have missed out what should happen if age is not greater than 18. So checking that is called as broken part. And security holes. As I said, where all in the code have we handled the security issues, or if there are any security holes. To check that, we'll be doing white box. They'll be doing white box testing. Okay. Understood what is white box testing? Okay. So again, we have testing levels in white box too. So unit testing, integration testing, and regression testing. So unit testing in white box is, they will check each and every. See, I have around 10 modules. Imagine. See, suppose I have module one and I have a set of code. Okay, and module two and I have a set of code, and module 3 and I have a set of code. So testing this single piece of code is called as unit testing. So checks if individual codes are error free. Now integration is, obviously, right, not functional wise, not module wise, but integrating these two pieces of code and testing if it is working as expected is called as integration testing. Code interaction between interfaces and modules. Suppose we have an interface also, a graphical user interface. For that we have a separate piece of code. So checking this interaction will also be done in integration testing of a white box. And regression testing, So what will happen is these two test cases, they'll be having it ready, right? So they will run all this together and they will test if this is fine. So that is the regression testing in white box. Please do not confuse this with your regression or integration. Okay, fine. Okay. Now going to the next. So, how the white box testing is performed? So, obviously, we should be they should be having a technique for developers to perform the white box testing or to write the test cases for the white box, right? So, how they will be doing it? We'll see that. Identify what should be tested. So, what is basically in what is the code basically about? So that should be identified and the source code should be understood. So actually, if I develop a code, right, I will not be testing. So if I have developed one and Pratibha has developed one and Raghunath has developed one and Kiran has developed one. So obviously we'll be swapping our code within each other and we'll be doing our white box testing. So at that time, obviously you should have a good idea of what the code is about and how the source code is written. Okay, that's what. Identify what should be tested, source code is understood, and test case creation and execution. Obviously, based on that, a test case should be created and it should be executed. So there are few white box design techniques. So can anyone say what are the black box design techniques? Testing or designing technique? Forgot? So are you there, everyone? I think Pratibha is talking something, but I'm not able to hear.
Ma'am,
Yeah.
please ask again, ma'am, the question.
No. What can anyone say? Few black box design techniques.
The dynamic
Yes.
decision making table,
Yes. Yes. Exactly. So boundary value
boundary
analysis,
balance,
state transition, decision
transition.
making, and we also have equivalence partitioning. Right. So in that way, we have few techniques in white box also. They are statement coverage, data flow, control flow testing, cyclomatic complexity, branch coverage, and path coverage. Okay, so we'll be seeing one by one. So statement coverage is, so if you take a code, okay, this is a code, so we have multiple statements inside the code, right? So this method, what they will do is they will help, it will help in covering most of the source code. Okay, can validate how much of application source code is executed. See, every time if you take any code in an application, based on what input you give only, that line of code will get executed. Not every time all lines of code will get executed, right? So how much of the source code is executed, to calculate that they'll be using statement coverage. So it ensures if each line of code is executed during testing. So it will also ensure if each line of code is executed during testing. So we have a formula for that. So how many executed statements are how many statements are executed divided by total statement into 100 will define the statement coverage percentage. Okay, now for example, if you see, you have a and B in this code, okay, and you're going to calculate sum. Sum is equal to A plus B, okay. And what you're going to do is, if your sum is greater than 0, then result you have to print result is greater than 0. Else you'll be printing result is less than 0. So now, as per this formula, okay, what you're going to do is, now I'm giving A as minus 1, okay, and I'm giving B as minus 3. So what is going to be this value of sum? Minus 4, right? So first this statement is executed. Next it will come to this statement. If sum is greater than 0, it is checking this, so this statement will be executed. No, so this statement will be avoided and it will go to else statement, and then it will print it is less than 0. So how many statements are executed here? 1, 2, 3, 4. So totally how many statements are there? 1, 2, 3, 4, 5. So your coverage will be 4 by 5 into 100. Understood how they calculate statement coverage? Okay. So now going to the next one, data flow testing. So here you see, in some I have saved a plus b, in some I'm calculating, I'm checking if it is greater, and suppose I am printing sum. So this is how the data is flowing from here, from this variable to this variable it is flowing, from this variable to this variable it is flowing, from this variable to this variable it is flowing, right? So checking the order of the data flow, how the data flow, in which order the data flow is happening. So checking that will be done in data flow testing. It gathers the data and checks how variable helps in flow of data. So here how this variable and where it is getting flowed, they'll be checking in data flow. Okay. And sequences the variable is checked to ensure data flow. So how, right? See here, instead of giving the if statement here, if I give it here before declaring the variable, obviously this is not going to work, right? Because we don't have a variable declared at all. So at that time, what you have to do is you have to ensure that this sum is defined properly, sorry, sum is verified properly after it is defined. So do that will also be taken care by the data flow testing. It checks on variable definition and variable usage. Suppose I define a variable as integer, okay, but what I do is I try to insert string into that. So that should not be, that should also not be done, right? So checking that also will be done in a data flow testing. Understood? So control flow testing. So now see, control flow is nothing but here in this example, if you see, this is a control. Okay, that is based on a value, the decision is taken and the control will be switched. Okay, so I think someone is joining. Okay, so testing that control flow, how from which control, how this control is handled, what type of statement is executed inside that. So testing that will be taken care in the control flow. So focuses on the order or flow of execution of the statements in the code. That is, in the if else, if I take after if, this should be checked. If this is not matching only, I have to go to the else statement. So that type of what to say, testing will be done in control flow. Test cases is created based on the control structure. Okay, so this can also be called as flow graph notation. That is flow graph notation testing, because we have notations. That is, we have a flow graph in this, and we have notation. So we'll see what type of notations are used. We have a node. Node means, node will denote in order in which statement should flow. See, if I say if a equal to b, then do this or do that. So deciding that, right? So that will be done in a node. And edge will be what to say is direction of the control flow. I'll show in you in the next example. Decision flow is obviously which node should be picked up next. To decide that, we'll be having decision node. Junction node is where multiple two or three what to say controls go and meet, right? That will be called as junction node. I'll show you one by one. So in this example, int age, we have age. If age is greater than 18, print you are eligible for voter id. Okay, else not eligible for voter card. So now this is how the flow graph notation or the control flow will look. Okay, so they are starting. So what they are getting the input as, they're getting it as age. So now here comes your decision. Okay, so if age is greater than 18, what they are going to do? they will, if this matches, if the ages matches, then it will go to the yes. If it doesn't match, it will go to no. So here it comes, the comes the, what to say, the edges. Okay, edges means that is which direction the flow goes. So if the eligible, if it is eligible, then stop. If it is not eligible, also stop. Okay, so if something does not match or something happens, then it should stop. Okay, so now what happens, you can see we have a edge here, we have a edge here, we have a edge here, right? So these, this will be called as, this stop will be called as junction node. Okay, understand? I know it is confusing. Just try to understand what it is only. Okay, don't go much deep into it. Just understand what it is. That much is enough. Okay. So now going to the next, we'll see cyclomatic complexity. So cyclomatic complexity, again, it is about how complex the logic inside the code is. Okay, if they have written a what is it, a decision making statement, and it is complex, to check the complexity based on the input. Okay, focuses on the logical complexity of a code based on decision making statement. It is also a graphical based on decision making. Okay, how they'll, how complex my code is. So to find out that, the complexity will be edges minus node plus 2. See, I'll show you here. So for the same example, what they do is, see, they put it as, this will be node 1, right? This will be node 1, this will be again a node 2, then this will be node 3, and this will be node, sorry, node 4, and this will be node 5, and this will be node 6. So they are calculating how many nodes are there, right? So edges, how many edges we have one, right? This, these are edges, 1, 2, 3, 4, 5, 6, 7. I think I have put it wrong here. 7 we have. So there are 7 edges and 6 nodes. Okay, so how they will define the complexity is 7 minus 6 plus 2. They will say the complexity is 3. If it is a very big code, and if the complexity is going to be very high, then at that time what will happen is, they will obviously the complexity of that code will based on the will be changed depending on the what to say, the flow of the program. Okay, this is the cyclomatic. Sorry,
What is just plus two man?
sorry.
What about that plus two man?
Sorry, I didn't get you.
What about that plus two?
Test tool.
Why should we keep that plus two? 7 minus 6.
Oh no,
Plus one.
that is a formula. Okay, see, if you say
I
edges
can't check
minus
now. Okay.
node plus 2, that is a formula. Okay, here we have this formula, right? Number of executed by total statement into 100. So they have that formula. Or maybe I'll check. Okay, I'll check why this plus 2 is there. So this is about cyclomatic complexity. Okay, understood? So next is branch coverage. Branch coverage is obviously, it is going to check all the branches in the code. It covers all possible outcome, true or false. Or if you see here, see, this is a branch. One from here it goes to here, from here it goes to here. This is a branch. From here it goes to here, from here it goes to, this is a branch. So we are having two, right? So covers all possible outcomes. If it is a true or false, whatever it is, you have to get the total number of branches in your code. So that is called as branch coverage. So obviously it is number of the branching paths. Okay, and next is path coverage. Path coverage is how many paths, again, 1, 2, 3, 4, 5, 6, 7. So putting all the paths, counting all the paths and putting, will come under your path coverage. So covers all statement and also decision coverages. Okay, so that is about your white box testing technique. We don't have much in that. I just wanted you people to understand what it is about. So any questions here?
Ma'am, can you please give a recap about the traceability matrix?
Requirement traceability? Yeah, I'll give. What about Kiran? Kiran, you have raised your hand, I guess.
To be honest, it's very confusing for me.
Yeah, I understand. Because yeah, it is completely about white box, right? You need not worry, okay? You just, this is very theoretical thing only, okay? So you need not worry.
Yeah, if you don't mind, can you explain the last two sides? I mean, the path and
You want branch and path.
a branch and path.
So here, right, you
Yes,
have,
that. What is exactly branch and path?
so branch is like, see, based on the decision, your branch will change, right? See, if the age is 19, you'll go to this branch, right? If your age is 17, this branch will be taken. So this is the branch, okay? So we have two branches here, but path is, whatever the, what to say, input is, you have to just pick the count of the path. See, you have one, two, three, then here four, then you have five, you have six, and you have seven. So the total coverage of all these statements, right? So that will be in your path coverage.
Okay.
Okay. So anybody else have any questions in this? If not, we can go to requirement traceability. If you have any questions in any other topics, you can just let me know. We can cover it for today.
Ma'am, one small doubt regarding. Ma'am, we will complete by tomorrow manual testing, no, ma'am?
Yes.
Will Institute inform us about the next
Yeah, they'll be
class?
informing you. Yeah. I'll put a message saying that the manual, uh, this is over, session is over. So after that, they'll be like informing you about the next session. So if you, what to say, if you start going to your automation and then you try to come back to this topic and try understanding, you'll understand it quite well. Because this is, ma'am, mostly about the coding, right? So obviously, once you start learning your Java programming and also the automation, right? Then after that, if you come again to this topic, you'll be able to understand what is statement coverage, control flow, and all. Now because you're new to this, it might be confusing. So any more questions? Okay, I'll tell about requirement traceability quickly. Okay, then what we'll do is, you people are like quite sure about the agile concepts, right? I have few questions. Okay, today I'll, from few interview questions, I'll ask you people from that, okay, today. Is it fine for everyone? Okay. So, and tomorrow, about the manual, we'll have a interview again. Okay. So now, once again. Okay. So now you want to know what is the requirement traceability matrices, right, Pratibha? So anybody else have any other questions? Okay. So, okay, this is the test case. Okay, this is the test case for a requirement. The requirement ID is requirement one. Okay, so I have written around two test cases for this, two or 10 or 100, how much ever it can be. So I have to, in this way, we'll be writing multiple test cases for all the requirements. Okay, so at that time, we have to ensure if all the requirements are covered in my test case. Am I correct? And after execution, we should also ensure if any new something which is not part of the functionality, or imagine I have requirement 2 and I have written test cases, and during execution, what before execution what happens, they say requirement 2 is not needed. So we have to have a what to say, traceability of which test case is covered for requirement 2 or requirement 1, or for anything if I want to remove it, or if I have a new scenario included for requirement 1, I need to come and write again, update this test case again, and I have to have a map, traceability of where this what is it require, sorry, this requirement and the test case needs to be mapped, and where the test case needs to be updated. So to have a track of these things, we'll be preparing a requirement traceability matrix. Okay, so now in this, so how we'll be having is requirement id. So we'll be here having either requirement 1, requirement 2, or epic. As we are now into agile, we'll be having epic number. Okay, and story id again, it should be pulled from should it should be for this epic. So for this epic we have 1, 2, 3 stories, and for this story I have one test case written. If I have multiple, I can again write include it over here in the next what is it, next thing. Okay, next line. And for story 2 I have one test case, and for story 3 I have one test case. And now the test result is, obviously I will check what is SW001. If it is passed, yes, this is passed, all the steps are passed for SW001, so here I will mark it as pass. Same way I'll check for SW002, it is pass. Now imagine SW003 is failing and it's having a bug id. So what happens is we should mark it as fail, and we should give a defect id over here, and also the defect status. So in this way, imagine the what to say, immediately your test lead or your manager comes in as, see, I have bug 001, for which requirement it is, which test case you have mapped it into. If they ask you for that type of questions, you can immediately pull this requirement traceability matrix, and you can give them a detail. See, bug 1 is failing for test case SW003, and it is part of epic 1. So you will have a clear picture, right? So this is the main purpose of requirement traceability matrix. Okay.
Yes, ma'am.
Okay, so any other questions?